Measures of central tendency refer to mean, median, and mode. And if you look here, the mean, sometimes we refer to it as the average, actually more often than not we refer to it as the average, is the sum of the numbers divided by how many numbers there are. The median is the middle number, but what's important to remember when it's a middle number, the numbers have to be written in order. That's why a stem and leaf plot can be helpful, because remember, a stem and leaf plot puts the numbers in order. It says if it's an even data set, you just take the two middle numbers and divide by 2 to find out what's in the middle. The mode is the number that occurs most frequently. So when you have a data set, whatever occurs the most often, that's the mode. It can have more than one mode, or there can be no mode. So let's look at finding measures of central tendency. It says find the measures of central tendency of the numbers given below. These numbers right here come from what we did creating a stem and leaf plot. Okay, so this is a stem and leaf plot we created earlier. And what I did is I took these numbers and wrote them out. That's why a stem and leaf plot is helpful, because if we're just given a bunch of random numbers, to find certain things such as the median, it's important to write them in order. Now, measures of central tendency are mean, median, and mode. To find the mean, you don't need to have the numbers in order. But to find the mean means we have to add all of these numbers up. So you have to go 1 plus 3 plus 6 plus 7 plus 8 plus 10. So if you were to do that and you were to add all of these up, you would come up with 853. Okay, so again, to find the mean, it's the sum. So add all these numbers up. That would work out to be 853. And then you have to divide by how many there are. 1, 2, 3, 4. If you count them all out, there are 27. So you add them all up. Again, mean is another word for average if we were to find the average of all these. Okay, whoops, if I can spell correctly. The average of all these numbers, you're going to add them all up and divide by how many there are. So if you take 853 and you divide by 27, you get approximately 32. Not exactly, but approximately. Okay, and again, if I'm referring to these as ages. Oops. It actually works out to be 31.592, so on and so forth. So 31.6 or approximately 32. That's the mean. Add them up, divide by how many there are. The median has to be the middle number. Now what you could do here, one trick is just to start crossing out the front and last. 1 and 58 cancel each other out, 3 and 55 cancel each other out, 6 and 52. But with a large data set, that can be kind of difficult. So another way to do it is we said that there were 27. If I take 27 and I divide it by 2, I get 13.5. If I were to count out 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay? And then count 13 from each side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 on the left and 13 on the right means my median is going to be 40. Okay, again, we could have crossed out the first and last and second to the second one's in, and we would come up with 40. Or we can just say, hey, I'm going to have 13 on each side because it's an odd data set, so we know there's one number in the middle. If this had worked out to be 14, well, then I'd have two numbers in the middle, and I'd add them up and divide by 2. But the median is the middle number when it's written in order. That's why stem and leaf plot's important. The mode is the number that occurs most often. Now you could figure out the mode by looking up here and seeing what occurs most often. Stem and leaf plots are helpful for that because you can see repeats. There are no repeats in this row. There's no repeats in this row, none in this row, but look at here. I have 2 zeros, I have 2 1s, I have 2 2s. Okay, look at what that represents. 40, 2 41s, and 2 42s. So the mode, remember, can be no mode, one mode, more than one mode. 40, 41, and 42 are all the modes. So again, measures of central tendency. The mean, add them all up, divide by how many there are. The median is going to be the middle number when they're written in order. And the mode is the number that occurs most frequently. There can be no mode, one mode, or more than one mode. Let's look at one more example. If you look at this histogram right here, it says a tire manufacturer conducts a survey of 118 people who had purchased a particular type of tire. Each person was asked to report the number of miles driven before replacing the tires. Responses are shown in the histogram. Find the median and mode of the data. So if we look at that, here's the number of responses. Here's the miles. So somewhere between, probably about one person said they only got 14 miles. Maybe 2 people said 15 miles. About 5 people got 16, and so on and so forth. But notice it kind of mirrors itself. Okay, both 19 and 21 had about 18 responses. Both 18 and 22 had about 14 responses. So if we think of the median is the middle number. The middle number, and these are in order, 14 through 26, is going to be right here in the middle at 20. Now, miles of use is 20,000, so we should write 20,000 miles. Okay. Now the mode is the number of occurs that most often. So all you have to do in a histogram, because what a histogram does is it shows the frequency of something. Like we said, one person said 14, one person said 26. 2 people said 15, 2 people said 25. 20 people said 20,000 miles. So our mode is going to be also 20,000 because it occurs most frequently. It is the highest column. Okay? So in this case, our median and our mode both are the same. That's not always true, but when you have a nice even distribution of data, okay, the median, since it puts it in order, is going to be in the middle, and the mode is going to be the highest column.